Hello again. Today we are going to start our new unit over functions, but before we get into functions, we need to define a new vocab word. That vocab word is a relation. All right, so a relation is a relationship between two variables. It explains which x values and which y values pair together. They can be represented as lists, mappings, and what we'll use most often will be tables and graphs. The domain. The domain are all of the x values. Domain comes from what's called the independent variable. And then the range is your list of all of your y values. And your range comes from the dependent variable. Dependent, that should be an ENT there. All right, so an ordered pair. You use parentheses around your ordered pair, and that is your x, comma, followed by your y. We start off with x because it's your independent variable, and that tells you how far to the left and not to the right you move on a graph. And then comma, the y value, tells you how far up and down you move. And again, you'll need parentheses around those to represent your ordered pair. All right, so this first example, we have the relation. So it's a set of ordered pairs. Okay, we have our first relation that's given to us as a list. So we have 1, 2, 3, 4 ordered pairs. Now what I'm going to do is I'm going to represent this list as a table. All right, so again, remember an ordered pair is x, comma, y. So my first x value is -2, and the y value that it pairs with is 5. So my x column and my y column, notice my rows form an ordered pair. So then I would also have 0, 6. So 0 is the x, 6 is the y. I have 3, 2. So 3, 2 forms an ordered pair, and then 5 and -1. The way that a mapping works is that you will list all of your x values in your first oval, and you'll list all of your y values in your second oval. Okay. Now, do not repeat any values. So if you have more than one ordered pair that has the same x, only write it down once. Same with your y values. And the way that you normally list these is going in increasing or ascending order. So starting off with your lowest. So our smallest x is -2. And then we have 0. And then we have 3. And then we have 5. Our y values, same thing. I'm going to go in ascending order. So the smallest y value that we have is -1. And then the next smallest is 2, and then 5, and then 6. Had I repeated anything in one of the ovals, I would have just written it once. And so then the way that this mapping works, to know which number -2 gets paired with, is you just draw arrows. So -2 gets paired with 5, so you'll draw an arrow from -2 to 5. 0 gets paired with 6, so you draw an arrow from 0 to 6. 3 gets paired with 2, so you draw an arrow from 3 to 2, and 5 gets paired with -1. All right, so this is probably the least familiar way that you probably won't be very familiar with working with a mapping because we don't use it that often, but that is how it works, is you list all of the elements of the domain, all of the x values in the first oval, all of the elements of the range in the second oval, and then you just draw your arrows saying which elements of the domain get paired with which element of the range. All right, then the last one, the one that you're probably most familiar with, graphing your ordered pairs. So here at 0, 0, where your x, so this is your x-axis, and then you have your y-axis, which is your vertical number line. You start off at 0, 0, the origin, and then your x tells you how far to move on the x-axis. And then your y value tells you how far from where you've already moved, where you're going to go up or down, how far you move on the y-axis. All right, so our first ordered pair is negative 2, 5. So I go to negative 2 on the x-axis, and then 5 means I'll go up 5. And then I would plot my point. 0, 6 tells me I don't move left or right any. I stay at 0 on the x-axis, but on the y-axis, I go up to positive 6. 3, 2 tells me I go to 3 on the x-axis, and then I go up 2 for the y. And then 5, negative 1 tells me I go to positive 5 on the x-axis, and then down 1. All right, so it looks like my first ordered pair that I plotted, which was negative 2, 5, that would be in my second quadrant. So a little bit about the coordinate plane. You have your x-axis, you have your y-axis, and it splits into 4 quadrants. Where both your x and your y values are positive is called quadrant 1. In quadrant 2, you have negative x values, but you have positive y values. In quadrant 3, you have both negative x and negative y values. And in quadrant 4, you have positive x values and negative y values. All right, so the ordered pair negative 2, 5 is up in quadrant 2. The ordered pair 0, 6 is not in a quadrant. Instead, it's on the y-axis. The ordered pair 3, 2 is in quadrant 1, and the ordered pair 5, negative 1 is in quadrant 4. All right, now that we know what a relation is, which again is just a list of ordered pairs, a function, so some relations are going to be functions. All functions are relations. So a function is a relation in which each element of the domain, and remember domain, those are your x values, where each element of the domain is paired with exactly one element. I don't know why there's another blank here. You don't need that. Is paired with exactly one element of the range. Don't forget that your range, that's your y values. All right, there will be 2 tests for us to see whether or not our relations are functions. And if it's given to you, if your relation is given to you as a table, a list, or a mapping, the easiest way to tell if you have a function is look to see if your x values, your domain, do they repeat? If they do not repeat, then you have a function. If you have any repeating x values, then you do not have a function. Now, for your graphs, especially when we start getting to continuous graphs, which means that they could keep going, it's not just plotting individual points. Okay, so when you get to a continuous graph, there's going to be a different method that you're going to want to use, because you won't be able to pick off all of the ordered pairs to check to see if the domain, if the x values repeat. So the easier way for graphs is to use what's called the vertical, vertical, vertical line test. So the way that this works is if you draw in a vertical line anywhere on the graph, so it might go through your graph, it might not go through the graph at all, anywhere on the coordinate plane, if you draw a vertical line that's straight up and down, if it goes through more than one point on the graph, okay, it is not a function. Can only go through 1 or 0 points on your graph. But if it goes through more than one, any vertical line by itself, that means that you do not have a function. All right, so now let's do some examples. So identify the domain and range of each of the relations, determine whether each example represents a function, explain why or why not. So our first one is represented to us as a table. So remember, the way that the table works is your ordered pairs are just formed by your rows. So your x column, your first column represents your x values, your second column represents your y values, and each row represents your ordered pairs. So we have the ordered pair negative 3, 2, negative 1, 4, 2, 2, and 2. This is actually the same ordered pair, so we don't need to list it twice. It's already on there. All right, so the domain are the x values. So in your x column, it's nice and easy. You're just going to list these out. Preferably, you're going to put these in ascending order, so going from smallest to largest. So this would be -3, -1, and +2. For the range, the y values, we have 2, 4, and 2. You're only going to list them once. So that would be 2 and 4. I'm not going to put this second 2 because I've already established that 2 is an element of the range. Is this a function? Well, let me look. Once I got rid of my repeating point, because it was the same point, it was just a duplicate, I have -3, I have -1, I have 2. Those are 3 unique numbers in my x's, and I don't care about my y values. Function, you're only looking at your x's, your domain. -3, -1, and 2, no repeating x's, which means yes, we have a function. Why was that again? No repeating x's. For our next one, it's given to us as a list. Notice that with our list, we have our braces, and then in our braces, we have our ordered pairs. So there are 3 of them. All right, and don't forget, in an ordered pair, it's x followed by y. So in our domain, we have our x values. Our first number is 1, and then 5, and then 1. So I'm just going to put 1 and 5. Those are our elements of the domain. I don't need to put a repeating value because it's already established to be an element of the domain. And then the y values would be 4, 2, and 2. So again, I'm going to put that in ascending order. So I'm going to go 2, 4. Is this a function? So looking at my x values, so 1, 5, and 1. Oh, I said 1 again, which means no, this is not a function because when x equals 1, we have a repeating value. So x equals 1 repeats. All right, the next one is given to us as a mapping. So -3, 0, 1, and 4, these are the elements of the domain. So my domain's really easy for me, -3, 0, 1, and 4. And the person that was doing this already put it in ascending order, which is what we want here. For our y values, we have -1, we have 1, we have 3, and we have 6. All right, now we need to tell, is this a function? So notice how -3 gets paired with 3. So if you want to, you can make your list of ordered pairs off to the side. -3 gets paired with 3. 0 gets paired with 6. There's an arrow going from 1 to -1. So 1, -1 forms an ordered pair. And then we have 4 that goes to 1. But we also have an arrow going from 4 to 6. All right, so here's a list of my ordered pairs. And notice when I listed them out, I have a repeating x value. 4 gets paired with 1. 4 also gets paired with 6, which means that this is not a function because x equals 4 repeats. An easier way to do that, rather than listing off all of the ordered pairs off to the side, is look to see your x values. Do you have multiple arrows stemming from the same number? And in this case, yes, we do, which means that we do not have a function because of that repeating x domain element. For the next one, another table. Okay, so again, your table, just look in your rows. These form your ordered pairs. So the element of the domain, the elements of the domain, we have -4, -2, -1, -2. So in ascending order, smallest number is -4, then -2, then -1. -2 repeats, so I'm not going to repeat it in my elements for my domain. My y values, I have 4, 6, and 3. So putting those in ascending order, that'd be 3, 4, and 6. Is this a function? So go back to the x values. -4, -2, -1, -2. Oh, we have repeats. So that means that no, this is not a function because when x equals -2, we have a repeating value. All right, this next one is given to me as a list. We have the braces around our ordered pairs. So our x values, remember it's x comma y. We have 4, 3, 2, 1, and 3. So putting that in ascending order, we'll go 1, 2, 3, and 4. And for the y values, we have 3, 5, 7, 9, and 6. So 3, 5, and then 7, 9, and 6. So 6, 7, 7, and 9. Is this a function? So we have 4, 3, 2, 1, 3. We have repeating x values of 3. So no, this is not a function because x equal 3 repeats. All right, now that we have our graph, so notice that all of these relations were tables or lists or mappings. We didn't do any graphs because I'm going to do something else to determine whether or not we have a function. And stating our domain and range won't always be as easy as just listing numbers. All right, so with our first graph, what we're going to do is we're going to look to see if we draw in any vertical lines, would we have a vertical line that touches our graph in 2 spots? All right, so to help me out with this, I'm going to get a shape and I'm going to have a line. So then I don't have to just draw the vertical lines. All right, so if I draw in my first vertical line that I have right here, here's a vertical line, that didn't cross through anything. Okay, actually it would, because if I extend this, the arrow means it keeps going forever. All right, there we go. So that would only intersect this part of my graph in one spot. It'd be right here, okay, when your x is about -10 and the y value is at 6. But it crosses through once, and that's fine. Vertical lines, if you're doing the vertical line test, it can cross through 0 times or 1 time, but that's it. So I'm drawing another vertical line. I'm going to do one right here. That vertical line, again, touches my graph just 1 time, which is fine. It passes so far. Let me draw on a vertical line at the y-axis. Again, it only touches once. If I come over here, draw on a vertical line, now it touches right here just once. The only point of interest is going to be when x is 2. So let me draw on a vertical line when x is 2. Here it touches the top graph. Here it also touches the bottom graph. And if you think back to your middle school days, when you have a closed-end circle, it means that you're including that point. So here it touches the vertical line twice, so 1 and 2, which means this is not a function. No. Why is it not a function? Because it fails the vertical line test. For the next one, it's basically the same graph. Okay, and if I draw in a vertical line anywhere else, it's only going to touch once. The only time that it might touch twice is when x is 2. Now, the difference between this graph and the previous graph is this is a closed-end circle, which means it's an included point. This open circle means it's not actually there. All right, so this point's not actually here. It's showing us that we're getting as close to this point as possible, but it's not actually included. So this is kind of tricky, and I wanted to address it because you'll have it on your homework where you'll have an open circle and a closed circle. Open circle is not actually included in the graph, but a closed circle is. So while it looks like it's going to fail the vertical line test, this point really isn't there. This one's the only one that's there, so that means it only touches once, which means it passes the vertical line test. So yes, it's a function. Why is it a function? Because it passes the vertical line test. Our last graph, if I draw in a vertical line, here it doesn't touch at all, that's fine. If I draw in this vertical line, it touches my graph once, which is fine. If I draw in this vertical line, here it intersects my graph up here at +6 and down here at -6. So because my vertical line touches more than one spot, it means no, it's not a function. Why is it not a function? Because it fails the vertical line test. Short lesson today, just a quick introduction to relations and functions. I believe most of this is review for you.